Hi everyone, today I'm going to teach you how to solve some functions in biology, and in the case of linear and quadratic functions. So this is linear and it says mass loss of a decomposing organism. A researcher measures the mass of a decomposing organism. On day 2, the mass is 8 kilograms, and on the day 5, the mass is 5 kilograms. This is our question. A. Find the equation of the linear function that describes the mass loss. B. How much mass will the organism have on the day 10? And C, when will the mass reach 2 kilograms? In the linear functions, we use always this equation to know what is our linear function in the problem. So we solve that. We have to know what is x and what is y. In this case, x are the days and y are the kilograms. In the problem, give us 2 points. These are 2 points, and we solve A. Like I said, this is the principal equation. Y, we know 2 y's. X, we know 2x. And B, I don't know what is B in this case. And M is our slope, but we can solve that. So in this case, we solve that. That gives us -1. And now we can replace the data in the principal equation. And with that, give us B. B, it's equal 10. And with that, we can know our linear function in the problem. Now the B, we have to replace 10 in x because x are the days, and that gives us 0. The organism will have 2 kilograms, 0 kilograms on day 10, meaning it will have completed decomposed. And the C, when will the mass reach 2 kilograms? In this case, we replace y because that is the kilograms, and that gives us 8. The mass will reach 2 kilograms on day 8. And this is the graphic. The problem don't ask about that, but we can do it. And we can put our 2 questions. So, like we know, x are the days, and y are the kilograms. This is C, and this is B. Now, the quadratic function. Metabolism and body temperature of a mammal. The metabolic rate of a small mammal varies with environmental temperature and follows the next equation. This is our principal equation, where m of t is the metabolic rate in kilocalories per day, and T is the temperature in degrees Celsius. So this is our questions. A, what is the metabolic rate at 0 degrees Celsius? B, at a temperature does the metabolism reach its maximum? This is in Spanish is eje de simetría. So we know the equation. And C, how does the metabolic rate change as temperature increases? So now we solve that. This is our equation. And this is our x and y in the plano cartesiano. So A, what is the metabolic rate at 0 degrees? We replace 0 in T, and that gives us at 0 degrees, the metabolic rate is 50 kilocalories per day. And B, at what temperature does the metabolism reach its maximum? So as I said, this is in Spanish el eje de simetría, and now we can solve that with the formula. This is we replace the data, and that gives us 10. And now we have to replace 10 in our principal equation. So this is our principal equation, and we replace the data, and that gives us the answer that is at 10 degrees, the maximum metabolic rate is 80 kilocalories per day. So we can do the graphic, and this is what I say. We can put the points. This is B, the maximum point. and A, where Y it's kilocalories per day, and X is the temperature in degrees Celsius. That is all. Thank you.